In this video, I'll discuss the need for Nano Server. As of the summer of 2015, Nano Server is still in technical preview. As such, its name could change before the final release date. Its original code name was Tuva, spelled T-U-V-A, so the name still could change. Nano Server is born of the requirements and limitations of a full server. A full server is one where we've got the local GUI management capabilities, which increases the resource utilization on that host and potentially even the attack surface because there's more running. So we want to offer the services that a traditional server can offer over the network, but we want to have a more lightweight footprint. So Nano Server then is well suited as a virtualization or an application server in a data center because it can scale well. A full Windows Server image or virtual hard disk could equal out to approximately 8.3 gigabytes. If we do that remote installation over a network, then we're consuming network bandwidth, and that's only for a single server image or single virtual hard disk. If we perform live virtual machine migrations from one Hyper-V host to another, that still results in network traffic. Even though we're not migrating the storage, we're still migrating a memory map file that's equivalent to the size of the RAM allocated to that VM guest. So given enough virtual machines that have to be drained from a Hyper-V host and live migrated elsewhere, that could turn out to be a lot of network bandwidth. Then we have to store server image files that are really much larger than they need to be. In the past, with the Windows Server operating system, all of the source files for roles and features were installed along with your installation of the operating system, even if you never used them. So that needlessly wasted space. That's no longer the case anymore, and it's one of the many reasons why Nano Server is very small and efficient. Some patches applied to the Windows Server operating system or applications running within it require a reboot. And so the more that we have installed, the more the potential is for reboots after having applied patches. It seems like a waste if some of those patched components might never be used. And reboots take time. So on a virtual machine host, if we have to do a reboot, that means we have to live migrate virtual machine workloads to another host elsewhere, patch the local VM host, reboot it, and then live migrate the workload back. So whether we're talking about a public or a private cloud, this seems like a waste of time and resources. And it is. This won't be as necessary with Nano Server due to the reduction of the number of reboots. Microsoft's target is to have up to 2 reboots required per year. On the security side, a full operating system installation has a potentially larger attack surface because there's more installed and more running. In the past, all roles and feature files were stored on the hard disk, even if they were never used. That also means that patches were applied. Having a local graphical user interface or GUI can be problematic on a server. Servers should really perform server functions and not desktop functions. So we need to isolate the client stack from the server stack. And that's the direction that Microsoft is heading in, which is definitely exemplified here with Nano Server. Nano Server has no local interface at all in any way, shape, or form. So it's designed to be managed remotely over the network. Virtual machine density is lower with higher resource utilization on a full operating system install. So the less that we have running, the more virtual machines we could potentially run. So with Nano Server, we have more efficiency with a lower cost. Nano Server is designed to be very lightweight, and it's designed to run on standard hardware, so there are no special hardware requirements. The operating system also uses the same driver model as a full Windows Server technical preview installation. But remember that Nano Server does not have a local GUI. It doesn't even have a local command line interface. So therefore, any driver installations that might require a graphical interface will not be supported on Nano unless they can be scripted or supplied with some kind of an answer file. Nano Server includes anti-malware in the form of Windows Defender out of the box, and it's ready to go and running. However, there is no GUI management interface available to run locally on the Nano Server since Nano Server doesn't support a local GUI interface. Here in PowerShell, I'm going to run the get-service commandlet looking for services that had the text DEF in their name. And I'm going to run that against my remote Nano server. When I do that, we can see that the Windows Defender service, in fact, is running on the remote Nano server. And that happens out of the box by default. Here in Server Manager, when we add servers to the console to manage them in this one interface, we can see the operating system version. And we can see our host Nano-1 is listed as Microsoft Windows Server Technical Preview 2, Tuva. Tuva was the code name for Nano Server previously, and the name is still subject to change before it gets released to public. If we go back to PowerShell, we can also take a look at the installed features on this local host. Now, this local host is a Windows Server Technical Preview 2 server with the GUI installed. Here I'm going to look for Windows features that contain the text anti. And we can see here that we've got the Windows Server anti-malware features, including the GUI component. So that's available because we've got a local server installation that does have the GUI component installed. Nano Server is designed to have a very small resource footprint. That means that in terms of disk space, we might have a Nano Server that consumes 0.41 gigabytes of space versus 8.3 gigabytes of space, which is about 1/20th of the space that we might use with a full server installation with GUI components. Now, with Server 2012 R2, we had all of the software installed on the hard disk, even if we weren't using some of those roles and features. But with Windows Server Technical Preview, including Nano Server, that's not the case. The source files are not installed by default on the machine. Microsoft has been quoted as stating that their goal is to make sure that Nano Server only requires a maximum of 2 reboots yearly. One of the reasons this is possible is because there's so much less running than there would be with a full server installation. So that means there's less to patch, which in turn means less potential reboots. Also, because we have such a small footprint with Nano Server, it means a smaller attack surface. There's less running. So from a security perspective, it's very attractive. Nano Server has very low resource requirements. One of the reasons is because there's no local interface to support, not even a command line interface. It's designed to be managed remotely using command line and graphical tools. Also, there's less disk storage required because it's a very small operating system and only the components that you're using are actually installed on the hard disk. Nano Server is a headless server implementation. This means that there's no local GUI or command line interface, so we can't interact with it locally. There's also no remote desktop support, and it's designed to be accessed over the network. We could also use PowerShell Direct on a Hyper-V host if we've got a Nano Server virtual machine. PowerShell Direct allows us to enter a remote session with a virtual machine, but not over the network. Instead, directly through the hypervisor into the guest operating system. Here in the Hyper-V Manager, we can see our Nano Server is running as a virtual machine. If I double-click to pull up the local interface so I can interact with that server, it'll open up a screen, but I'm not going to see very much because there is no local interface with Nano. There's no command line. There's no graphical interface. There's nothing. Again, it's designed to be managed remotely. We can use PowerShell to enter a remote session over the network by giving it the name or the IP address of the Nano host. Here I've entered enter-ps session, and then I've given it the name of my Nano server. You can see by the prompt, by the prefix of the prompt, that we're connected remotely to that Nano server. However, here in Technical Preview 2, there's a lot that still has yet to be implemented. For example, if I were to type get-service to get a list of services installed on that Nano server, I get a return result that says it doesn't know what that commandlet is. So not everything has yet been implemented with the Nano server, but we can enter it remotely over the network using enter PS session. We could also enter a PS session to that machine if it was running as a virtual guest on a Hyper-V host, but we would use the -VM name parameter instead of computer name parameter to connect to that server. What this would do is use PowerShell Direct to make a connection to that host instead of connecting over the network. If we're having problems over the network connecting to the Nano server, this would be another option. We've also got the option of adding the Nano Server, as I've already done here, to the Server Manager interface. That's done by going to the Manage menu and choosing Add Servers, where we might query Active Directory if the Nano Server is domain joined and add it to the Server Manager interface. So here it is added, and we can right-click on it and do a few things such as restarting the server remotely, working with it through Windows PowerShell, configuring NIC teaming, and so on. Nano Server only supports 64-bit computers. Additionally, features and roles will install like applications on Nano Server. That means that we have to specify the source file location, whether we're using PowerShell to install roles and features or whether we're using a remote GUI tool.